Welcome to your notes on trig graphs day 1. And so our goal today is to graph trig functions. To do that, I really want to show the connection between the unit circle and the graphs. So what I've done is included a completed unit circle. And your notes is blank, so pause the video and fill this out for me. Or if you remember how to fill it out, go ahead and fill it out and then double check it against this. Once you've completed that, scroll down to the bottom and we'll talk about how to actually graph. So the directions say to use the information to transform into the graph y equals the sine of x from negative 360 degrees to 360 degrees. So the first thing that I'm going to do is mark the major angles on the graph. So we'll do 90 degrees, 180 degrees, 270 degrees, 360 degrees. And the other direction, obviously, we've just got negatives of those angles. And then because there's nothing on the y-axis, we'll arbitrarily mark a 1 and a negative 1. Have them be roughly the same distance apart. So as we look at our graph, we know, or we look at the unit circle, we know that the sine values are essentially the y values of your coordinates. So if you start on your circle and work your way around, you will be able to see that the sine of 0 degrees is 0, sine of 90 degrees is 1, sine of 180 degrees is 0, sine of 270, the y value, you can even see it on the picture, is negative 1, and then 0 again at 360 degrees. Because the directions tell us to stop at 360, we're not going to go past that or draw a mark that we could continue infinitely. If we rotate the opposite direction around the circle at negative 90, we're back at 270. So our y value is negative 1, 0, 1, and 0. And then these are curves, so we want to make sure that we're kind of rounded. Oops, missed that a little bit. And there's our graph. We can see from this graph that we've essentially graphed 2 full periods or 2 full cycles of the sine graph or a sine wave. So we know that our period is going to be 360 degrees. The amplitude, basically how high or how low this graph is 1. And we know that our range goes from negative 1 to 1 inclusive, and our domain was given. If we were not given a domain, then this graph or this wave could cycle on indefinitely. Okay, we can now do the same thing for our cosine graph. So this time our domain is listed from negative 2 pi to pi. We'll still list the major angles, but this time in radians. So pi over 2, pi, 3 pi over 2, and 2 pi, and then the negatives to the left of your y-axis. Again, we know our cosine values go from 1 to negative 1, or negative 1 to 1 really. And if we use our unit circle and look at the x values, at 0, cosine has a value of 1. At pi over 2, it's 0. pi, it's -1. 3 pi over 2, it's back to 0. And at 2 pi, it's 1. And if we go in the opposite direction, we get the same types of values. And we have a very pretty curve. And we want to be careful to stop at 2 pi and -2 pi because we know that anything past that is outside of the domain. Our period is again 2 pi or 360 degrees. Our amplitude is still 1. And our range is still -1 to 1 as it was with the sine graph. For the tangent graph, we're going to basically overlay the sine and the cosine because we know that the tangent of x, actually I want to make this black, is equal to sine x over cosine x. So real quickly, I'll put in the angles again. And now we're going to look. So since tangent is the sine of x over the cosine of x, we know that anywhere that cosine is 0, we'll be dividing by 0, and tangent of x will be undefined. So we know that we'll have asymptotes at x equals pi over 2, x equals 3 pi over 2, x equals -pi, and x equals -3 pi over 2. And that'll continue on indefinitely, but since we have a domain of -2 pi to 2 pi, we can stop there. We also know that any time that the sine of x is equal to 0, the tangent of x will equal 0. So that will occur at the origin, at pi, at 2 pi, -pi, and -2 pi. We have to remind ourselves that the tangent of 45, or pi over 4, is equal to 1. So that would be roughly there. And the tangent of -pi over 4 is -1. So that'll give us the shape of our graph. And it'll just continue repeating in this fashion. So what we can see is that our period is not 2 pi in this case, but pi, and that we have asymptotes at x equals pi over 2 plus n pi. So every pi interval will get another asymptote. And our range this time is from -infinity to infinity. All right, let me know if you have any questions.